Hello, all, and welcome back to the lesson 5 in chapter 6, that is the projectile motion. The learning objectives of this lesson are solve physical problems involving velocity and solve problems on projectiles. In the coming sections, we will look into both of these objectives. The key words which you'll come across in this lesson are projectile, motion, acceleration, velocity. You might have come across few of these already beforehand. Anyways, we will recall them as we continue in the coming sections. The first topic here is very basic. It is to identify initial conditions. Now, you might have remembered. Now, if you have a position, say this is the position, say P, position is P. Now, if you derive the position, you will get velocity derivation. So derivation will give you velocity, and if you derive the velocity, you will get acceleration. This is derivatives. Now we are dealing with integrals, integration. It starts from the other way around. If we integrate acceleration, here it is d by dx, okay? dy by dx, that's basically. If you integrate acceleration, you get velocity. If you integrate velocity, you will get the position. So this is how it works. So now it is very crucial to understand what is the initial conditions. Initial conditions means always at the time 0. So now y of t might be the height or the position at particular time t. But whenever t is 0, time is 0, that means it's initial condition. Now here let us see, an object is dropped from a height of 80 feet. You can see the 80 feet is where it starts. It is dropped from that feet. So now imagine this is a building. This is a building, and say this is somewhere 80 feet over here, and an object is being dropped from here. What is the initial height? With respect, this is 0, it's at 80 feet, so this will be the initial condition. At the time 0, it is already at 80, so y of 0 will be 80. Sorry for that. Now, there is no velocity information, so y dash of 0, that is the velocity, is 0 because it's not mentioned. Now, in the next problem, an object is dropped from a height of 100 feet. Here, the same thing, the initial velocity, initial height, the initial position is basically 100, whereas the velocity is not mentioned. In the third problem, we have an object released from a height of 60 feet with an upward velocity of 10 feet per second. Now, this is important because we have two things. An object is released from a height of 60. Okay, y of 0 is 60 feet with the upward velocity. Upward means positive, downward is negative. Upward velocity of 10 feet per second. So y dash will be 10. So this is the answer, plus for its upward. And it is y dash of 0 is 10 feet per second, whereas y of 0 is 60. Try this by yourself. Take time, pause the video now and solve it by yourself. I am sure you're all thorough in these type of questions by now. So over here, object is released from a height of 20 feet. Y of 0 is 20. Downward velocity is 4 feet per second. So y dash of 0 is minus 4. Why? Because it's downward. That's it. Now we will see a problem on finding the velocity of a diver at impact. So now, before we solve this problem, see now all the problems will be in this type. It is real world, it's simple, it's practical problem. You know, we have done these problems before. Basically, or you integrate acceleration, get the velocity, integrate velocity, get the position, and then see what you require. Now, I want to talk about this impact. What does impact mean exactly? Now over here, we will see the question and then I'll come back to this impact. If a diving board is 4.5 meters above the surface of the water and a diver starts with the initial velocity, see, the initial height or the position is given and the initial velocity is given in the upward direction, positive. what is the diver's velocity at impact. So now a person is diving board, in the ocean, they'll dive scale in the boat. So that is what he's doing. So he's already up above. The waves are going like this. He's up above over here, maybe at 4.5 meters. Okay, very high. So now they want to know, with the velocity already given, they want to know the diver's velocity at impact. Now, first thing, let's just write the given over here. H naught, H of 0 means initial condition. Height is 4.5. Sorry, this is 4.5 meters. I apologize for this mistake. It should be meters, not feet. And now over here, the velocity is given as 2.4 meter per second. I am sorry, this is m and this is plus 2.4. Okay, that is it. Now I will stop over here. Okay, let's see this. The step 2 before I go to impact. Let's see. We need to find h dash of t, where t is the impact time. Okay, now what is this exactly, impact time? Now, impact time means where it touches the particular, where it touches zero height. Now, let's see. It's basically like the intercepts. Okay, let me draw a straight line. So now imagine you go up like this and you come down over here. The impact over here is this particular point. Now, okay, that is not so accurate. Now it's something like this. You start from 4.5, right? Now we start from 4.5, and when is the impact? At this particular point, when it touches zero. So what do you understand? The impact velocity means h of t will be equal to 0. We don't know at what time. We don't know exactly at what time it touches at 0. But whenever this entire equation h of t is equal to 0, that is the impact time. I hope this is clear. You start at what? 4.5, right? Okay, at the time 0, at 0 time you start at 4.5. It eventually goes, right? At what time will it come down to 0? So that is the thing. At what time t? So that particular time is to be found out, needs to be found out. It's very important. That time t is the impact time, and that velocity at that particular time is the answer. Anyways, we will now solve it and then you will understand much better. Now we have find the velocity by integrating acceleration. I hope you all know what's the acceleration over here. H double dash. See, now over here position is h, velocity is derivative of it, so h dash. Acceleration is double derivative h double dash. Now you must know this by now. Acceleration due to gravity is negative 9.8 meter per second square. We have already used this before. If you have forgotten, no worries. Minus because it's downwards, acts downwards. And this is a constant 9.8 meter per second square. Now integrate this, you will get the velocity. Integration of h dash, h double dash of t is h dash of t. So integrate minus 9.8. What happens? Dt is, because you have to integrate this, it is minus 9.8 t. Because the integration of any constant, if it's 1, it is x. Okay, because if it's dx, now here we are dealing with dt. So we don't write x, we write t. That's the only thing. Now don't forget the plus c. A constant will always be added. Okay, what is that constant? How do we find it? Very simple. You know the initial velocity h of 0 is 2.4. So substitute over here and solve. See, what I mean is substitute the value of h dash of 0. When h dash of 0, what happens? Minus 9.8 t is 0, right? Plus c. So instead of t over here, we are making everything t equal to 0. That is the initial time. Because we know when h dash of t is 0, it is 2.4. So all we are doing is, instead of t we put 0, and over here we put 0. Okay, now solve it. H dash of t is 2.4. So we know 2.4, this becomes 0, is equal to c. So this is the constant value. So now what we write is the proper equation of the velocity. The velocity equation h dash of t is 9.8 t plus c. That is, c value we found out is 2.4. This is the velocity equation. What next? Next, we will find the impact time, which is very, very important. To find the impact time, we need to find the height, that is h dash of t, h of t, sorry, that is integrate this velocity, you will get the position or the height. So initial position, initial height. Integrate this, that is minus 9.8 t plus 2.4. When you integrate it, look what happens. See, there is t, so it is 9.8 t square divided by 2 plus 2.4 just t. This 2 and 9.48, when you put it in the calculator, you will get 4.9. So minus 4.9 t square plus 2.4 t plus c. That is the answer. But again, we don't know what is c. What do? We let us put t as 0 and let us solve. T will be 0. So instead of t over here, everywhere it's 0. What is the h of 0 value? It's 4.5. So 4.5 is c, because this cancels. Anything that is having t will cancel. This cancels. It's 0, 0. 0 plus 0 is 0. C is equal to h of 0, that is 4.5. Next, h dash of t equals minus 4.9 t square plus 2.4 t, but the c value we found out is 4.5. Generally, for a quadratic or linear function, when we find the initial value, whatever is this initial value will be the answer. Only when it's trigonometric functions, when you have trigonometry over here, don't blindly take the c value as the initial conditions. C value might change depending on whether you have sine or cos. But when it's quadratic, this is linear, it's a quadratic, you can easily understand all this will become 0. So your constant will be basically your constant value will become the initial conditions. Now, this is important and crucial. Always the impact, the height will be 0. I told you, right? You start with over here when the height is 0, the position. So at what time h of 0 will be 0? So this is very important. Sorry, it is not h of 0, it is h of t. Okay, now that is very crucial, because sorry, this is okay, this is doesn't make sense. H of 0 is not 0, h of 0 is 4.5. I apologize for this mistake. It is h of t. I'll change this error. It is h of t must be equal to 0. So now just equate this to 0 and solve for the time, you will get the answer. So just equate it to 0. We have done this many times. Quadratic equation, mode phi 3. So all you need to do is put in mode phi 3, you will get two answers. Remember, negative time is not possible, so this is the correct answer. T is 1.23. This is the impact time. You will have only one correct answer. Now substitute this impact time of 1.2 seconds in the velocity equation. To find the impact velocity, just substitute t as 1.23 over here, or 1.2, and you will get the answer. That is the particular answer. So now again, I'll just recall over here, this h of t must be equal to 0. You will find the time. Take only the positive value of time. And then what do? After you find the time, put it back in the velocity equation. Instead of t, put 1.2 seconds, which is the impact time. So at impact time, over here t impact time, you will find the velocity. That is, just substitute over here, instead of t 1.2, it's negative 9.36. That is the impact velocity.